Imagine a computer chip that doesn't just process data faster, but actually processes it at the speed of light while consuming a fraction of the energy. For decades, we've been pushing silicon to its absolute breaking point, generating heat and draining power in the pursuit of smarter machines. But today, we are witnessing a fundamental shift. Researchers at the University of Pennsylvania have cracked the code on a hybrid light matter particle that is set to revolutionize artificial intelligence computing. In this video, we're going to dive deep into how these ultra-efficient particles work, why they solve the biggest bottleneck in modern AI, and what this means for the future of your smartphone, your self-driving car, and even quantum internet. Buckle up, because the era of electronic computing is about to get a massive upgrade from light itself. The core breakthrough here lies in the creation of a hybrid particle that combines the best traits of two worlds, photons and matter. Traditionally, if you want the speed of light, you use photons. But photons are notoriously difficult to control. They zip past each other without interacting, making it nearly impossible for them to perform the complex logical operations required by AI processors. On the flip side, electrons, the particles that power our current chips, are great at interacting and computing, but move much slower and generate significant heat when processing massive data streams. The team led by physicist Bo Zhen has engineered a solution, a particle that possesses the strong interactions of matter with the high-speed velocity of light. Think of it as giving photons a personality and the ability to talk to one another, while keeping their blistering pace. In practical terms, this means an AI chip powered by these hybrid particles could execute calculations orders of magnitude faster than current silicon-based GPUs. We aren't talking about a 10% improvement. We are looking at architectures that can handle the exponential data loads of next-generation generative models without the thermal throttling that currently limits server farms around the world. This isn't just an incremental update. It is a paradigm shift from electronic logic to optoelectronic hybrid logic, promising a future where AI runs in real time with latency measured in nanoseconds rather than milliseconds. Let's talk about power consumption, because this is the other half of the equation that makes this breakthrough so critical. Right now, data centers are energy hogs. Training a single large language model can consume as much electricity as thousands of households use in a year, and the heat generated requires massive cooling systems to manage. As AI models grow more complex, this energy demand is becoming unsustainable both economically and environmentally. The hybrid light matter particle changes the game entirely by replacing traditional electronic processes with ultra-efficient light-based technology. Light, or photons, carries information without electrical resistance. When you switch a circuit on and off using electrons, you lose energy to friction and heat. With these new particles, the signal travels at light speed with virtually zero thermal loss. Researchers suggest this could lead to chips that use a fraction of the current power draw for the same computational output. Imagine a laptop that runs complex AI tasks without needing a heavy battery or a cooling fan, or a data center that operates on renewable energy sources without blowing its budget on climate control systems. This efficiency isn't just a nice-to-have feature. It is a necessity for scaling AI to solve global problems like climate modeling and personalized medicine without draining the planet's resources. You might be wondering, if light is so efficient, why haven't we seen this everywhere yet? The answer lies in complexity. As chips grow more complex and process enormous amounts of data, integrating these new hybrid particles presents significant engineering challenges that traditional fabrication methods struggle to meet. Standard semiconductor manufacturing is built around electrons. Moving to a system where matter and light interact requires entirely new design paradigms and materials science breakthroughs. The research indicates that these problems become even more difficult as we try to miniaturize components, yet the potential payoff justifies the steep climb in development. The breakthrough involves solving how to confine these hybrid particles within nanoscale structures while maintaining their ability to interact strongly with data streams. It's akin to trying to fit a race car engine into a bicycle frame. It requires rethinking the entire chassis. However, early prototypes are showing immense promise, demonstrating that we can now build circuits where light does the heavy lifting of computation. This shift allows for higher density integration, packing more computing power into smaller spaces, which is crucial as our devices shrink and our expectations for performance skyrocket. It marks the transition from simply making transistors smaller to changing the fundamental nature of the compute unit itself. So what does this actually mean for you in 5 or 10 years? The implications are profound across every sector of technology we interact with daily. First, consider personal devices. With these ultra-efficient chips, smartphones and tablets could run local AI models that are currently too power-hungry to execute on mobile hardware. You won't need the cloud anymore. Your phone could generate realistic images, translate languages instantly, or analyze medical scans locally without ever leaving your pocket. Secondly, think about autonomous systems. Self-driving cars rely on processing terabytes of sensor data in split seconds. Current electronics often lag behind the real-time requirements of high-speed driving due to heat and latency limits. Hybrid light matter chips could provide the instant decision-making capability needed for fully safe, Level 5 autonomy, without overheating the vehicle's computer systems. Finally, this technology paves the way for a more sustainable digital future. By drastically reducing the energy footprint of computing, we can continue to advance AI without hitting the wall of climate constraints. We are moving from an era of brute force computing to one of elegant, efficient intelligence, where speed and sustainability go hand in hand. The development of this hybrid light matter particle by researchers at Penn represents a definitive turning point in our technological evolution. We are moving past the limitations of silicon, embracing a future where AI is as fast as light and as green as nature allows it to be. This isn't science fiction. It's the next chapter in hardware history that will redefine what machines can do while respecting the planet we live on. If you found this deep dive into the future of computing as fascinating as I did, make sure to hit that like button so we can keep exploring these breakthroughs together. And subscribe now to stay ahead of the curve as these technologies move from the lab to your life. The age of light-powered intelligence has begun.